Came across a very interesting book on linear algebra using exterior products, or the wedge product, by Sergei Winitzki. I really like the way this book was published. It's very high quality, and it is actually a Lulu book. There it is, lulu.com. So it was privately published, individually published, or not part of any publishing house. It's just a Lulu book with a perfect binding and high quality. And yeah, very interesting. So let's go through the table of contents. It's got an intro, then linear algebra without coordinates. And I can see here vector spaces, linear maps, subspaces, isomorphisms, direct sums, dual conjugate vector space, the tensor product of vector spaces, and linear maps and tensors. Then some index notation and some direct notation. And the exterior product itself described in detail. Then some basic applications, some advanced applications. I see here the Cayley-Hamilton theorem. Yeah. Some formulas, then the scalar product, and then an appendix with complex numbers. Permutations, matrices, and just the license. Now, it's a small book. It does not have answers in the back, but I really like how original it is. It really is just, not a typical linear algebra book. And if I had infinite time, I would actually have done this book right after Friedberg and Spence, just for fun. But in the future, I reserve the right, of course, if I have the time, to use this book, to do this book, as I get back into analysis and do some differential geometry. If I show here Baby Rudin, the wedge product is used in chapter 11 of Baby Rudin. And of course, it's got these rules where if you change the order of a wedge product, you get the negative. And if you try to do the wedge product on the same space twice, you get a 0. And of course, in differential, this is Baby Rudin, of course. I should have said that, should have shown it. And then in a baby differential geometry book, some differential geometry books also use the wedge product. And here are those rules laid out as well. Getting back to this book, I want to highlight the remark on the origin of exterior. I think it's really great to have that in a book. Yeah, so it's a more modern formulation dating back to Grassmann from 1844. The vector A cross B, really, it's a cross product, is the oriented area of a parallelogram. This will be found in typical and beginner linear algebra books. And then the 3 vector is the 3 volume and for a parallelepiped. And then anything that includes the same space twice. The product, we can say, it says right here, we can interpret this geometrically by saying that the product of 2 volumes is 0 if these volumes have a vector in common. Yeah, and Grassmann called it the antisymmetric product. So let me zoom out. As I usually do, I'll just let you check out the preface and read it at your own leisure. Yeah, some notation, some sample problems, some basic results just to get you started. And then it gets going with linear algebra. Lays out the geometry. Looking for, so it's got examples of vector spaces, examples in general. It does have some comments where he's basically solving a problem, asking it as a question, then lays out a long answer. This is really very detailed. And then exercises. at the end of each section. Some definitions, some remarks, examples. Yeah, but the exercises are in the middle of the text, which is a little weird to my taste, but that's, it's 6 of one, half a dozen of the other. There are hints for some exercises. There are solutions for some exercises. Of course, if and when I get around to doing this book, I would have a piece of paper that covered whenever I would look at an exercise so that I could solve it. I'm not looking at this answer, by the way, just I like to do that. I'm just showing it to you so you can see it yourself. Looking for the proofs. Yeah, here's a proof. A coordinate-free proof and a proof using matrices. I like that. I like that. It lays it out in 2 different ways. He'll ask a question, then give a rather detailed answer. So I love the way this book would help me with geometry. And at some point, I really want to get my act together with geometry. So definitely, if I get around to it, I would love for this book to be one of the beginning books to get into geometry, just because you can never learn enough linear algebra. Direct sums of vector spaces. The dual basis. Hyperplanes. The tensor product. I'm very interested in learning about the tensor product. Yeah, he lays out really detailed examples, presents a question, gives out an answer. Very much the way it would be done in a lecture. And that really makes this book actually pretty good for self-learning, minus the not having answers in the back. But if you get around to this book and it's not your first linear algebra book, I don't see that as such a big deal, because you would have already done a lot of problems where you had the answers to check your work in self-learning mode. Of course, if you were taking a class, you wouldn't have that problem at all. Yeah, it's a very fresh take on linear algebra, very different from the way it is usually taught, but it's got some concepts that I'm very, very curious about. That's basically the bottom line as I page through the book. And of course, the book is not too long. I'm almost paging through the entire book. I remember direct notation from physics. Yeah. Then he gets down to the meat of the exterior product, laying out the geometry, some very nice figures. Yeah. Of course, that was that paragraph that I was talking about earlier. Yeah, lots of wedge products. I love that. Something that I want to learn a lot more about. Anyways, I'm not going to page through the whole book. I think you get a feel for what it is like. Very original take. Definitely a book for me to do if I ever have the chance, because of course I've got a long list of books that I want to do, and so much time left to do all of this work. Wish I was 25. Yeah, nice book.